I'm Milt Melander.
Welcome to the Vulcan Hydroelectric Replica in Appleton, Wisconsin. Come on in and we'll do the demonstration for you. This is the first commercial usage of using water power to generate electricity. In 1882, Henry Rogers built the Hearthstone as a showplace, as a bribe to his wife, because he was taking her from the civilization of Denver, Colorado, to the wilds of Wisconsin. Hearthstone is about 1.5 miles upriver from this point. About the time that Henry Rogers discovered the use of the electric light bulb, I think he was already working on this idea. He had contacted 3 other gentlemen to set up a utility to be able to sell light to the common man.
The insulators you see up top, you see there's 6 lines. 2 of them were to power the exterior lighting here, and the other 4 were directed over toward Lawrence University, what is now Lawrence University, to the Smith houses, which were the 2 houses that were electrically powered. Electricity at that point was charged by the number of bulbs that you had. Each bulb had equivalent to about a 50-watt output, and they're charging anywhere between $1.25 to $1.75 per bulb.
The operator would watch 2 tattletale lamps for brightness. He had no meters, no gauges, just the amount of light that he was putting out. When it got to a certain point, he would hit the switch, the knife switch up here, and release the current. But how this whole thing worked looked basically like this. So what's happening is the belts are running the armature over here to the wire brushes. You generate electricity with these. This is electromagnetic. This is DC current, direct current, so you had to be within line of sight. There was an argument at this time, this was 1882, DC versus alternating current. This was DC, this lasted till about 1890. Actually, the life of this one was very short-lived because the demand for light was further than what this particular building could handle.
This is a K generator, Kirchhoff 1880s. It is a DC creates DC power. Now, components of this are, these are electromagnets. They're a center core of hard iron wrapped with copper wires interior. There's 6 columns on this particular one. These are permanent magnets, and they're set up also in line. In the late 1700s, early 1800s, a physicist by the name of Faraday, I believe he was a Scotsman, was playing with magnetism, and he determined that by moving a wire through a magnetic field, you could create power, electrical power. And he was proving that with using a voltmeter on it, so he could see exactly how far it was going. This is doing basically the same thing. Your unit in here is wired, is a combination of a number of wires going through there. It's running through a magnetic field. Power is then run through these wires and out. Running through this is the armature, which is this. Power is taken off by carbon brushes right here. These are your set screws that set exactly how they're pitched on there. If this were in actuality generating power, you'd be seeing a blue spark in this area. This is the throw switch. Once you get generation happening, the switch is pushed over. That transfers power to these columns, which again kind of super magnify the amount of magnetism in the bottom. It's sort of like shifting from first gear to third gear. Power comes off up here, goes through a series of blocks, which are called fuse blocks. It's a heavier wire with a lighter wire connecting between them. If it gets an overload, it'll blow that rather than blowing a main wire coming through, or light bulbs. This is a rheostat that controls kind of a fine control on exactly how much power you're putting out. These are to lubricate your axle. Axle's coming through here on the armature. The K generator is in here is one of three that still exist. One is still in the Edison Museum in Michigan. The other has been in a private collection down in Texas, and we have the third one here. Very, very rare. When they were in the process of building this duplicate, the original duplicate was built over in Trolley Square area by Pullman's. That was the headquarters of We Electric. We Electric was putting this together for the 50th anniversary of the electrification of Appleton. In order to put this thing together, they took the original plans, which were just sketches, and assembled various pieces to make everything come together. One of the objectives was to get a K generator mock-up. So Wisconsin-Michigan Power shipped a crew over to Michigan to the Henry Ford Museum, where there was one on display. They were going to make basically a fake copy of it. Henry Ford heard about this and immediately insisted that they have the original K generator here. He had one spare one there. Next thing you know, it was over here on a truck, and they started putting it together. When Wisconsin-Michigan Power moved its headquarters from here down to Milwaukee, the replica was given to the city and moved over to this location. What most people think of when they think of a mill is like a grist mill. Grist mills typically are run with a vertical water wheel. However, in order to get better control and more power out of it, this has got a horizontal water wheel called an Elmer wheel. The Elmer wheel was connected to the West Canal via pen shaft or sluice.
They would take water off of a thing called the West Canal. It was a man-made canal. Drop it down the berm. It had already dropped about 3 feet from Oneida Street. Dropped it down the berm, so another 10 feet, into a man-made sluice that this sat on. The operator would get in here, raise the sluice or lower the sluice to try and get the water running underneath.
Water would come down a drop of approximately 10 feet, hit that wheel and spin it. This wheel has an advantage over a normal wheel, over a vertical wheel, in that you have adjustability of the vanes on it. So you can control the power and the speed it's running at by controlling the flow of water to it. So it gives you far more control than you'd ever get with a vertical wheel. That power is transferred via a shaft from the wheel itself up to the gearing system in the interior. The gearing system up top basically turns it around from horizontal back to vertical again in order to operate the generator.
In 1987, they decided to donate it to the city of Appleton. Actually, Parks and Rec is the entity that owns this. This is pretty well the exact copy. The only thing that is different, we've had to change out the belts. Initially, they were using leather belts like this. But the problem with leather, it has to be dressed. And for a number of years, this particular unit sat and the belts became dry and very stretched out. We were always a little wary of the belts. One day we were in here to have somebody check out everything that was going on in here to make sure mechanically we were good. We turned it on and the belts just kind of disintegrated. Luckily, the person that we were using to check it out was able to get a hold of these belts that we have on here right now. They are canvas and linen. Again, historically correct for that period of time. The biggest difference was cow leather was easier and cheaper and to get a hold of at that point in time. Now, it's the opposite. So we were able to put on these canvas and leather belts, get things back up and running. The replica was used to educate a number of classrooms. They would have grade school kids come over, that they would run this for the children. So a lot of people do remember this from their grade school days. The flag has been passed to us. We are doing this to educate people along the hydroelectric trail, which is something relatively new in Appleton, and it's part of the trail systems of the Fox River Valley. This is run by the Appleton Historical Society in partnership with the City of Appleton.